Alright guys, so what we're going to start looking at today are logarithms. And you learned about logs back in Algebra 2, and if you remember, a log is really just an exponential equation written in a different way. And the way it's really written is, b, on this example, b is my base, a is what we call the argument, and then x is the exponent. And then the way these work, if I want to write this as if I were to write this instead as an exponential equation, it would be b to the x power is equal to a. So I'm going in a little circle. So it's b to the x is equal to a. So I start with a little number and I just go in a circle until I get to that a. So it's the base raised to the exponent, and that gives me the argument. Now, if there is no base written, okay, like this example down here, which says log of 100, if there's no base, it doesn't mean there's no number, it's just an implied 10, okay? So if there's no base, the base is 10. So for this example here, I could actually evaluate that, because that means if I write that as an exponent, 10 to the x power equals 100, which we know is 2. So the log of 100 is 2. Okay, so if I were to rewrite this in exponential form, that's exactly what I just did to solve it. That's 10 squared is equal to 100. Now, we also learned in Algebra 2 about the natural log, which is abbreviated as ln. So that was my natural log. And a natural log is just a log with a base of e. So if I wanted to, actually that would be the same thing as writing log e. Okay, but instead of writing log e, I just write ln for natural log. And if you remember, e is actually a number, okay? E is a number, it's Euler's number, and it's a approximation. It's 2.718, and it kind of keeps going like pi does. Okay, so e actually is a number. And one common example you'll see a lot is the natural log of e. So if you were to rewrite this in exponential form, then the natural log of e would be my base is e, so e to the blank power, e to the blank power is equal to e. So the only thing that could possibly be is 1. So the natural log of e is 1. Now one way I like to remember this is I feel like sometimes the ln of e, if you think about it, kind of looks like the word 1, if you just kind of turn that L into a 0 there, or if you think of it as actually is a 1. Okay, so the natural log of e is just 1, because e to the first power is e. So anytime you see natural log, just remember there's a little e at the bottom. Another example of that, if I had the natural log of e squared, the natural log of e squared would have to equal 2, because remember, there's a little e down there, and e to the second power would equal e squared. So even though it's not written, there's an e there. Alright. So now what we're going to look at is actually evaluating some logs or solving some logs. And this first one, we have an x in the base. So I need to try and figure out what that x is. So what I'm going to do is I'm going to rewrite this in exponential form. Remember, it goes in a circle, where x to the second power is equal to 16. So x squared is equal to 16. And you guys know that the number squared that gives me 16 is 4. So x is equal to 4. Alright, then I've got a different one here. This time my x is in a different place, but it's still going to be the same process. Rewrite it as exponential. 3 to the negative 2 power is equal to x. So now I have to remember my exponent rules. A negative 2 power, that means I can move that to the bottom of a fraction and make it positive. So that's just going to end up being 1 over 9. Alright, sometimes they'll tell us to evaluate a log, and that's really just like solving it as if it were equal to x. That's really what we're doing. So I need to figure out 3 to the blank power is equal to 27. And we know that 3 cubed is equal to 27. So that means if I were to evaluate this, log base 3 of 27 is 3. And then the same idea here in my last one. I'm going to rewrite this in exponential function, in exponential form. So if I have 9 raised to the blank power, I'm going to get 27. Now this one is a little bit harder. So what I'm going to do is I'm going to rewrite this, because I can't really think easily of a number to get from 9 to 27. If I square 9, it's going to be way too big. If I take the square root of 9, it's going to be way too small. But what I do know is both of these numbers can be rewritten as a form of 3, because 3 squared is 9, and I know that 3 cubed is 27. So now the only way for these functions to be the same is if my exponents are the same. And I am going to rewrite this without the parentheses, because that's going to be the same thing as 2x. So the only way for these to work out is if 2x is equal to 3. And if I just solve that, I know that x has to be 3 over 2. So log base 9 of 27 is 3/2. Now some of you might be able to see that just from being really familiar with taking your roots and raising numbers to powers, but if you have to work it out, that's okay. Just try to find a common base that allows you to rewrite it. And that's all we have for the introduction of logs. We're going to move on a little bit more after this and look at some properties of them and other things we can do, but that's it to start.